All right, this second video, we're going to talk through this question, convert r equals sine of theta to rectangular coordinates. And there's some kind of key ideas that we should talk about before we walk through all of this. So last week, we talked about some basics of polar graphing. One of the things that we talked about was with polar graphing, so if I have a polar coordinate on a graph. So suppose this is the point r comma theta. And I'm going to expand this so we can see this a little better. So we have r theta, and I know that this is r and this is theta. We have in rectangular, this is x and this is y. So this graph in picture helps us to see some special relationships. And we talked about these last week a little bit, but I want to remind you of them. So we know this is a right triangle, so we know that x squared plus y squared has to equal r squared. That's relationship number one. We also know that if I want to do the sine of theta is y over r. So what that means is that since sine of theta is y over r times the sine of theta has to equal y, okay? And we could do the same with cosine. We could say cosine of theta is x over r. Therefore, I realize that light's a little bit bright there, but I'll write it down here. So therefore, r cosine of theta is x. All right, so these are some key things that will kind of help us make sense of the next problem I'm going to do. So the one on the left here deals with r and theta, which is polar coordinates. The one on the right is rectangular. Same thing with this one. And this conversion will help us a lot as we work through the next problem. All right, so in the problem that we're going to do, so let me grab my eraser there. We want to show that if I have r equals sine of theta, when I graph that, it's a circle. And so we need to work through some steps. The first thing we're going to do is we're going to multiply both sides by r. And the reason we're going to do that is, well, it will help us convert it into rectangular. Our goal is that we convert this into rectangular coordinates so that we can kind of confirm, oh yeah, that is a circle. And it has a center at 0.5 and it has a radius of 0.5 like we saw in the previous video. So if I multiply both sides by r, so times r on both sides, I'm going to end up with r squared on this side, and I'm going to end up with r sine of theta on this side. So r squared, so a minute ago we talked about the fact that I know that r squared is the same as x squared plus y squared. That was what we just had on that picture earlier. So if I want to convert this into rectangular coordinates, x's and y's, I'm going to change r squared to x squared plus y squared. And then we just confirmed a minute ago also that when I have r sine of theta, that's the same as y. So now I have an equation that involves just x's and y's. So our next step is we're going to rewrite this in a form that will show us what the center is and what the radius is. So the other thing that we didn't spend a ton of time talking about this year, but I want to make sure, actually I don't know if we ever really talked about it, but the general form of a circle. So the general form of a circle, anytime I have a circle in rectangular coordinates, it's going to be x minus r, or x minus h squared plus y minus k squared equals r squared. And the h and the k are always the center of the circle, and the r is the radius of the circle. So I want to show you a minute, since I can pull up Desmos on here, kind of what that looks like. So on Desmos, we can play with that idea. And so if I wanted to graph x minus 1, or we'll do x minus 2 squared, and then plus y minus 1 squared, oops, equals 16. Okay, so you can see in this one that the point 2 comma 1 is my center. So 2, 1. So x minus 2, that's the 2 is the x of the center. The 1 is the y of the center. And then we can also see that the distance from the center to the edge, this radius length, is 4. So right here you can see this is the 0.61. This is the 0.21. That's a radius of 4. You could go in any of these points and see the same thing. This is a radius of 4. So 4 squared is 16. Now the cool thing on Desmos is I could play with this. I could call this H, and I could call this K. Oops. And so if I make that H and that K, and I just add sliders, I don't need this anymore. I could play with the H. So that H, you can see, is moving the left-right of the center, and the K is changing the location of the up and down of that center, the Y coordinate of that center. So I would encourage you to play around on your own. If you want to play with this number, you could call it, we could just call this R squared. And so I'm going to add a slider R. And so let's watch what happens when we play this. Oops. Here we go. It's not letting me slide it for some reason, but you can see R is the radius. So that's a quick summary of circles in rectangular coordinates. So keep that in mind as we work through this problem. So our goal here, remember we started by multiplying by R on both sides, and we got this. Then we changed into X's and Y's. Now what I'm going to do is work to rewrite that into a form that I recognize in rectangular coordinates as the form of the circle. So I'm going to move the y to be with a y squared. So I'm going to subtract it. So I'm going to have plus y squared minus y equals 0. Now next, what I'm going to do is try to complete this square. So I'm going to have x squared plus y squared minus y. So earlier this year we talked a little bit about completing the square, actually quite a bit. And so if I have y squared and then I have 1y, so if I want to complete the square, we know that we have to take half of that b value. So like if this was 4y, it'd have 2y here and 2y here. Or if this was 8y, I'd have 4 and 4. So since I have 1y here, I'm actually going to think of this as 0.5y and 0.5y. So 0.5y and 0.5y. And then so to think about what do I need to complete that square? Well, 0.5 times 0.5 or 0.25. So I'm going to add 0.25 here, and I'm going to add 0.25 here. So this is going to give me x squared plus, now the whole reason I did that, and you might be pretty confused now, why am I even doing this, is so that I can write this as a perfect square. Because if you look up here in the form of the circle, it's written as a perfect square. So I want to do the same thing here. I want to think about, okay, this must be y times y, and then what times what gives you 0.25 and adds to give you -1. So since it's -1, it's got to be minus and minus. It's got to be the same number. It's a perfect square. So it's 0.5 and 0.5. Okay, and that's 0.25. So if I go one more step, this is going to leave me with x squared. So we'll get x squared plus y minus 0.5 squared equals, and if we really want to kind of rewrite that other side as a circle, in the circle form where we have the r squared, I want to think about, well, what when I square it gives me 0.25, and that's just going to be 0.5 squared. So now I can confirm, this is exactly what I got when I did polar coordinates. I have a circle with radius 0.5, so radius equals 0.5. You can use lowercase r. Radius is 0.5, and I can see that the center here, well, there's no number with the x, so that might seem kind of strange to you because in our equation up here we have h. Well, what number really wouldn't matter? That would be 0. So I could think of this if I wanted to get crazy, x minus 0 squared. And then, so I can see, yep, the center of this is going to be 0, and then the y is going to be 0.5. And that's exactly what we got when we graphed it with polar. So these steps help you to convert between our original rectangular or polar equation into rectangular. So that's the first problem. And so the other thing that you were going to do and need to do, one second. So on that handout, the next problem asks you to do the same with cosine. Now, I'm going to just preview that a little bit with this part, but same thing to start. You're gonna multiply both sides by r to start there, and then you're going to have an equation you can easily convert into x's and y's. The steps are identical to what I just did up here, just that instead of having your center in one spot, it's going to be located in just kind of the opposite spot. So think through this. If you have questions, feel free to email me, and I'd be glad to help you. But I feel like it's very similar to what we just did. So make sure you watch the video and the steps I just walked through a few times as you work through this if you need to. Then moving on through the rest of this handout, the next one asks you to plot r, or initially just kind of think through this. If I'm plotting r equals sine of theta plus 2, what's the farthest out from the origin that we could go? So sine, this is where an understanding of range is important. So sine, if we think about what is the biggest that sine could be, so the biggest, sine is a y coordinate, and so the biggest it could be is 1. So if I think, okay, sine alone would be 1, and then I'm adding 2, that should help you to think about what is the biggest this could be. Same with what is the smallest, but it didn't ask that, but that kind of gives you an idea of where your radius lengths are going to be. And actually, when we think about where the smallest is, that will help us answer part B. Okay, so you're going to plot that. Feel free to fill in that table. They just, on this handout, these are gray at pi over 4 and 3 pi over 4, etc., because on your graph paper, this graph paper didn't include those spots. So don't worry too much about that. And then this conversion here, give that a shot. Don't get stressed about that if this one doesn't convert nearly as nicely. So if you get stuck on this, that's fine. Don't worry about that one. And then finally, I'd like you to graph r equals cosine of 2 theta. And with that one, you're going to want to make the table. You're going to want to do your best to fill in these points, and you're going to get an interesting graph. There's a good chance you're going to mess it up. I'm not going to lie. Trying to do it by hand is not easy. But do your best. I want you to give it a shot. And then the last thing on here is for you to go to Desmos and try graphing each of these to confirm. Desmos does a great job of graphing polar graphs. I posted a video in the assignment that helps you with that process of graphing. You also need to do one other Desmos exploration for this week and play around with some cool polar graphs. So have fun. If you have questions, don't hesitate to let me know. Send me an email. I'd be glad to do a Google Meet with any of you individually. The other option is every Tuesday, I'm available from 2 to 3 for our Google Meet. So have a great week. We'll talk to you later.